Hello dear aspirants, this is Dr. Sourav Sir's classes. Our contact number is 98367930076 and I am repeating our contact number, which is 98367930076, and our email ID is souravsirclasses@gmail.com. So if you have any mathematical query, doubts or anything, so please feel free to contact, then our team can arrange it out clearing session for you. After that you can join our regular batches, one-on-one sessions and our online classes, so that will be beneficial for your preparation of upcoming examinations like ISI, CMI, TIFR, NBHM, etc. So please feel free to contact if you need any help from us. So this question is the question of the NBHM, that means the National Boards of Higher Mathematics written examination of the year of 2025, and the question is telling us that let S11 be the symmetric group of on 11 letters. How many subgroups of order 11 are there in S11? So now we are here to determine the number of the subgroups of order 11 in S11. So let's analyze the problem step by step. Okay. So let me. So now we are going to identify the possible subgroups. So the symmetric subgroup S11 consists of all 11 permutation of 11 elements. So our the order of S11 is equals to 11 factorial. So a subgroup of order 11 must be a cyclic group of prime order 11, which means it must be generated by a single element of order 11. The only elements of order 11 in S11 are 11 cycles. That is the permutations that cycle through 11 elements in one complete cycle. So now our step 2 will be the counting of 11 cycles. So an 11 cycle is a permutation of all 11 elements in a single cycle, which can be written as this A1, A2, A3 dot up to A11. Okay. So the number of distinct 11 cycles is given by the number of ways, which is let me correct. Yeah. So yeah, given by the number of ways to arrange 11 elements in a cycle, which is 11 factorial by 11, that is equals to 10 factorial. So since cyclic permutations are equivalent up to rotation, we fix one element and arrange the remaining 10 elements in any order. Okay. So now our step 3 will be counting distinct subgroups. So each 11 cycle generates a cyclic subgroup of order 11. The group Z11 has exactly these things, that means that has exactly phi of 11, that means our phi is the Euler tangent, that is equals to what, phi of 11, that means equals to 10 generators including the identity, meaning each subgroup contains exactly 10 distinct non-identity elements. Each subgroup corresponds to a unique set of 10 elements among the 11 cycles. Since each subgroup has 10 non-trivial elements, the total number of such subgroups is, that will be 10 factorial by 10, so that will be 9 factorial. So thus the number of the subgroups of order 11 in S11, the correct answer of this will be our 9 factorial. Okay. So this is our correct answer of this question. So again, I am telling that if you have any mathematical queries, doubts or anything, so please feel free to call on this number, or you can WhatsApp also. Rather, you can drop an email to our email ID. Then you can join as a student to our institution. Then you can enjoy all the services of Dr. Sourav Sir's classes. Okay. Thank you guys. Hope you understood. Thank you.